All right, so this is a review for your Chapter 4 test. So I'm just going to go through the practice test problems that I assigned you in class. So starting with number one. Number one, we've got three parts for this, parts A through C. So the function, I'll write that down first. Okay, so part A, find the y-intercept, the equation of the axis of symmetry, and the vertex. So y-intercept, this is super easy when you're in standard form, because for the y-intercept, remember what you do is you plug in 0 for x. So the y-intercept would be, you'd plug in 0 here, so that would be 0, 0 here, so that would be 0. So it'd be 0 plus 0 minus 7. So all you have left is that negative 7. So that's your y-intercept. For the axis of symmetry, we've got a formula. The x-coordinate is negative b over 2a. And what this is, b is whatever the number is in front of the x, so negative 4. And then over 2 times a, and a is whatever's in front of the x squared, which for us is technically a 1. So this is 2 times 1, which of course is 2. So this reduces down to a negative 2. So that's the axis of symmetry. It's going to be a vertical line. We're going to draw it as a dotted line, and it gives us a symmetry of the parabola where you could fold it in half and it'd be perfectly symmetrical on both sides. And then the vertex. The vertex, what you do, you know the vertex is going to fall on this vertical line. And so what we do is we plug this point into the original function. So we want to find the function value when x is negative 2. So we've got negative 2 squared plus 4 times negative 2, and then minus 7. So negative 2 squared comes out to be positive 4. 4 times negative 2 is negative 8, and then minus 7. So this is a negative 11. So that's all the information we've got so far. So we're gonna slightly tweak what the directions say, because this is what I want you to do when you're taking the test on this stuff. So when you go to graph it, all you need is these three things. So our y-intercept is negative 7. So let's go by 2's. So 2, 4, 6 means 7 goes right there between 6 and 8. That's my y-intercept. It's always going to be on this vertical y-axis. Then I draw in the axis of symmetry. So negative 1, negative 2. So draw in a dotted line. And so we know our parabola is symmetric around that line. Then the vertex always gets drawn on the axis of symmetry. So let's look for our y-coordinate. That's 7. So 8, 10, 12. So 11 would be halfway between 10 and 12. And then what we do to get a third point, that way we can get the shape, is we mirror image the y-intercept over to the other side. So here the y-intercept is 2 units away, so we go 2 more units away and we plot a symmetry point. And then we can just use that to connect the dots, and that is our parabola. Alright, next one I assigned was 4. Number 4, we're doing this max and min stuff. Okay, so to determine whether something has a max or a min, you look at this x squared term. X squared is positive, that means it opens up just like this one does, and so if it opens upward like this, we've got a min. Okay, so we know we're going to have a min, and then to find the value of that min, you're going to find the vertex. So same formula, same process that we did up above. So start with the x coordinate. The formula is negative b over 2a, so we have negative 10 over 2 times 1. So the x-coordinate is negative 5. That's not what we want, though. We want the actual function value. So we plug negative 5 into the function. So we have negative 5 squared plus 10 times negative 5 plus 25. So this gives me 25, and then a negative 50, and then a positive 25. So all those things actually just go to 0, because I have a positive 50 and a negative 50. So my minimum value is 0. So you'd say that you have a minimum, that would be part of your answer, and then the minimum value, the lowest y value on the graph, is 0. Okay, then next I gave you specific directions for the next chunk of problems, because in the book they just tell you to use any method, but I want to make sure you're practicing all of them. So for number 6, I told you to solve by factoring. Okay, so this one, whenever you have just an x squared out front, that's going to be your more basic method of factoring. So you know that you can do just x times x, because x times x will give you an x squared. And then when you're kind of reversing the foiling process, you're trying to figure out what two numbers go here and here. You need them to multiply to a negative 9, and you need them to add to a negative 8. So the only things that multiply to 9 are either 3 and 3 or 1 and 9. So if we do a negative 9 and a positive 1, those two numbers multiply to negative 9, and they add to a negative 8. So to solve by factoring, remember what you do is you take each factor and you set it equal to 0. That's the last step. Don't just factor and stop. So here I add 9 to both sides, so 9 is one of my answers. Here I subtract 1 from both sides, so negative 1 is my other answer. So 2 solutions. Next one, 7, you guys were doing that just right on your calculator. So here's our function. Nice decimal problem here. Okay, so the calculator ones, remember the directions will say if it's not an exact answer, then you just state the integers between which the answer can be found or something like that. Okay, so what you do is you open up a graph page on your calculator, just like this, and we want to type in this part right here. You don't type in the equals 0, because you're looking for where it equals 0, which is when it's on the x-axis. So you just type in the negative 4.8 x squared plus 1.6x and then plus 24. Okay, and then hit enter. Okay, so our graph looks like this. So first of all, if this thing is in the way, you can always click and hold it and kind of drag it out of the way. And then we can see our x-axis more clearly. All right, so it doesn't fall nice and neatly on the line. If we look at this one, it's in between two values. So literally what you'd write for that is between 2 and 3. So you can write it out in words. You could literally write between 2 and 3, or you could write it like this. It's technically the more proper mathematical way to write it. Let's look at the second one. The second one looks like it's almost on that line, but if you were to zoom in a little bit closer, it's actually between negative 2 and negative 3. Let me show you really quick, just a little zoom in. So if we zoom in right about there, zoom, you can see it's actually not right on the line. All right, so that's somewhere between negative 3 and negative 2 for the other one. Again, you can use this notation, or you can literally write between 2 and 3. Between negative 3 and negative 2. All right, the next one I told you to do by the quadratic formula. It's number 8. So we've got 12x squared plus 15x minus 4. So notice one thing about these, all 3 of these were already given to you in standard form. If you weren't, you have to get them there by getting everything on one side and 0 on the other. So let me write down the quadratic formula first so we can use it. So negative b plus or minus the square root of b squared minus 4ac all over 2a. That needs to be memorized. You don't want to lose free points just because you don't have the formula memorized. All right, so we're going to plug everything in. So this number right here is a, that's what's in front of the x squared. This number right here is b, and the negative 4 is c. Okay, so x equals, so negative b is a negative 15 plus or minus the square root of negative 15 squared minus 4, and then a is 12 and b is a negative 4, and all of that over 2a, so 2 times 12. Okay, that's like the first step where I just plugged everything in. So negative 15 plus or minus, let's start with what's underneath here, so let me plug that strand in. So on a calculator page, in parentheses, negative 15 squared. If you're squaring a negative number, it has to be in parentheses. Okay, and then minus 4 times 12 times negative 4. Okay, so under the square root, I have 417. And then all over 2 times 12, which comes out to be 24. So if you look at 417, it's definitely not a perfect square. It doesn't even really have any perfect square factors. It's not divisible by 9. It's definitely not divisible by 16 or 25. And so this is actually the best that you can do. It gives us 2 irrational numbers. Okay. Next one, this is the last one in this section, is number 9. This one we're going to do by completing the square. Now we've got all our methods down. Okay, so this one, if you remember with completing the square, we actually are supposed to have it in a slightly different form. Completing the square, there are 2 things. First of all, the x squared has to be by itself, nothing in front of it. And so this is good. If there was like a 2 or a 3, you'd have to divide it out. Here, the constant is actually supposed to be over on the right-hand side. So start there. So add the 17/4 to both sides. So that is your setup before you start completing the square. Nothing in front of the x squared with your constant over on the right-hand side. Okay, so what we do, we take this middle number, and we've got a two-step process. You cut it in half, and then you square it. I feel like we've said this so many times. Cut it in half and square it. So just a little side work over here. Start with the -7. You cut it in half. Okay, and then what we do is we square it. So we square the -7, we get 49. We square the 2 and we get 4. So that is the number that we add to both sides. So now that we've added it to the left, we've completed our perfect square trinomial, which is what we needed to do. But you can't just add something to the left without also adding it to the right. And look, common denominator, saves a little work for us. Over here on the left, this factors down. So we're trying to figure out when we're factoring what multiplies to a 49/4 and adds to a -7. That would be -7/2 and -7/2. If you add them together, you get -7. If you square the -7/2, you get 49/4. And so it factors down like that. The trick is it's half of this middle number that goes in here. And then we add these together. 17 plus 49 gives us what, 66? Okay, so 66 over 4. We're just about done here. The next thing we're going to do is take the square root of both sides. Over here on the left, we have canceled out the squared, and so we just have x minus 7/2. Over here on the right, whenever we square a number, we always start with a plus or minus. The 66, it's not a perfect square, doesn't have any perfect square factors, so we just leave it as the square root of 66. But the square root of 4 is 2, so we can square root the denominator. Okay, so last thing we're going to do is we're going to add this 7/2 to both sides. Okay, so x equals, we have the 7/2 that we just moved over, and then plus or minus root 66 over 2. Okay, and that is our answer by completing the square. Okay, on to the next section. Now we're moving on to number 13. Multiple choice. Which equation below has roots at -6 and positive 1/5? Okay, so here's how you do this. If you know what your roots are, you can kind of work backwards. Look at like this problem. If you know that these are your roots, you could come up with the factors. And once you come up with the factors, you can FOIL it out and get the equation. So that's what we're doing. If we know that our root is -6, that means we had a factor of x plus 6. And if we know that one of our factors is positive 1/5, we have x minus 1/5. And in order to be an equation, it has to have an equal sign. So you set it equal to 0. Now what we do is we FOIL out. So x times x is x squared. X times -1/5 is a -1/5 x. 6 times x is 6x. And then we have 6 times -1/5, so that gives us a -6/5 equals 0. Okay, now we don't ever want to deal with fractions in an equation like this. So what you do is you figure out what number would clear out the fractions. They both have denominators of 5. So what I'm going to do is multiply the entire equation by 5. So 5 times x squared, of course, gives me 5x squared. 5 times -1/5 x gives me a -x. 5 times 6x gives me 30x. 5 times -6/5, the 5's cancel and I have a -6. And then 5 times 0 is still just 0. So let me combine up my like terms. I have a 5x squared. When I combine up these middle terms here, I get a positive 29x and then a -6. And there we go. That is my equation. And so what that matches with is letter C. Okay, number 16 and 17. 16, this is a complex number thing. So 3 minus 4i minus the quantity 9 minus 5i. These ones are pretty easy. First of all, pay attention to whether there's subtraction, addition, or nothing in the middle. Obviously, if there's subtraction or addition, you're adding or subtracting. If there's nothing in the middle, that means you're FOILing. So here, since there's subtraction, make sure you're subtracting. So we subtract 3 minus 9. So I'm actually going to write out the work here. So 3 minus 9, and then back over to the left, we have a -4i minus -5i. Okay, so first of all, this changes to plus a positive, and let's combine like terms. 3 minus 9 gives me a -6, and then a -4i and a positive 5i gives me a positive 1i. And that's it. That's your answer. Okay, 17. 17, we've got 4i and then over the quantity 4 minus I. What you do to simplify these up, remember you're not allowed to have imaginary numbers in the denominator. And so you take the conjugate of the denominator. Conjugate is the same expression, but you switch the middle operation. So instead of subtraction, we do addition. So you multiply by 4 plus I. That's called the conjugate, which means you also multiply the numerator by 4 plus I. And so now watch what happens when we do that. So 4I times 4 gives me a 16I. 4I times I gives me 4I squared. Now it's the denominator. FOIL everything out. 4 times 4 is 16. 4 times I is 4I. Negative I times 4 is negative 4I. And then negative I times I is a negative I squared. Okay, so let's clean up. So 16I. And then 4I squared, remember, this one's super important for these complex numbers. I squared is equal to negative 1. So that means that that is equal to a negative 4. In the denominator, these two things cancel. I have 16, and then negative I squared would be equal to positive 1. Okay, so in the numerator, switch the order. The negative 4 should be before the positive 16I. My denominator, I add together, and I just get 17. For my final answer, I should have the real part separate and then the imaginary part separate. So what I do is I just split them both up over 17. All right, so that's number 17. We've got 18 and 20. 18 is another multiple choice. Which value of c makes the trinomial x squared minus 12x plus c a perfect square trinomial? Remember the way this works? I start with this middle number. I cut it in half. And then I square it. So negative 6 squared gives me 36. So my answer would be 36, which is letter H. Okay, 20 is my next one. I have 5x squared equals negative 6x plus 1. So in a couple steps, I'm going to be doing the quadratic formula. What we need to do before we do the quadratic formula is get this into standard form, which means adding the 6x to both sides, subtracting 1 from both sides, so we can get everything on the left. Okay, first step, part A. Part A, find the value of the discriminant. So the discriminant is just the expression b squared minus 4ac. It's just the part under the square root. So b squared, 6 squared, which is 36, and then minus 4 times a is 5, and then times c, which is negative 1. Okay, so I get 36, and then minus, this all multiplies to a negative 20. So minus a negative 20 means plus 20. So I get 56. The value of my discriminant is 56. That's part A. Part B says describe the number and the type of roots. So in the quadratic formula, I'll have a 56 underneath the square root. Because my number is positive, I'm going to have two answers. But because 56 is not a perfect square, it's not going to come out nice, neat, and clean like the rational answers, so it's going to be two irrational answers. Okay, last thing is to use the quadratic formula to actually solve. So x equals, we start with negative b, so negative 6, plus or minus the square root of, we just found b squared minus 4ac, it was 56, then all over 2a. Okay, so take a look really quickly. 56 is divisible by 4, so we can clean all that up a little bit. So 56 is 4 times 14. So we've got negative 6 plus or minus, square root of 4 is 2, so we can write this as 2 root 14 over 10. And then my very final step here, if I ever have a common term between all three of these, like the 6, the 2, and the 10, I can reduce it down. So reduce everything down by 2. So the 2 is gone there, and I just have root 14 and then a 5. So that is your final answer for the quadratic formula. All right, just a couple more here. 22. We're doing 22 and adding a graph. So 3x squared plus 6x equals 2 plus y. So this one's weird. We've got some extra stuff on the side with the y. So subtract the 2. There we go. Now we've got the y by itself. Okay, so what we're doing with number 22 is we're getting it in vertex form. Okay, so I am just going to, much more comfortable having the y on that side. I don't know about you guys. So we look at this stuff right here, the x squared and the x term. First thing we notice is that there is a 3 in front of the x squared. There is not supposed to be a 3 in front of the x squared. So we're going to factor it out from those two terms. So divide out a 3 here, I'm left with just the x squared. Divide out a 3 here, and I'm left with a 2x. Leave a space, because we're going to need a constant in there. And then this negative 2, not the constant we need. We're just going to move it over to the side. We're not even going to divide out a 3. So we leave it like this. We are trying to figure out what constant goes here. So just like the completing the square stuff that we've done on a couple of problems now, we start with this middle number, cut it in half, and then square it. And when we square 1, we still get 1. So we had a 1 right here. That's the number that inside the parentheses will complete the square. However, we just randomly went and added something into the equation that wasn't there before. So what I technically just added was a 3, because this is now 3x squared plus 6x plus 3. So I technically added a 3 times 1, which is 3. I can't just add 3 to the equation just because I want to. So I balance it out by subtracting 3 from that same equation. So now it's all balanced. What I do is I simplify it up. So I get 3, and then this factors down to x plus 1, x plus 1. So I write it as x plus 1 squared. And then the negative 2 and negative 3 give me negative 5. Okay, so we are going to identify the vertex, axis of symmetry, and then the direction it opens. We're going to graph all this. Okay, so the vertex. Remember what I told you guys with the vertex is that x lies. So x is the opposite of what you see in here, which is a negative 1. Y tells the truth, so we still got a negative 5. Since the vertex is at the x value of negative 1, that means my axis of symmetry is at negative 1. Okay, so let's get a graph here. Negative 1, negative 5. Okay, and then from here, when I'm graphing from vertex form, I only need you to know two things. Number 1, whether it opens up or down, and you can look at the positive 3 for that, because the 3 is positive, it's opening upward. Second thing I need you to know is how wide or how narrow is my graph going to be. Because of this 3, not only do I know that it flips right side up, I know that it's going to be pretty narrow. Anything bigger than 1 is going to give me a narrow graph. So just give me a very general sketch of a narrow graph that goes through that vertex, and you are good. Okay, 2 more problems, just 24 and 25 left to go. Okay, so graph the quadratic inequality. Okay, so this thing, first of all, I'm going to add everything here over to the left-hand side because I don't like that the 3 is negative. Okay, so I moved all this stuff over. I left 0 over here, which means the inequality still stays the same. So I'm going to graph this. I'm going to graph it the same way that I graphed our very first problem. I'm going to use the y-intercepts. I'm going to use the vertex, everything like that. Okay, so my y-intercept is just 10, negative 10. It's whatever's hanging out on the end here. Because if I plug in 0 for these two, all I have left is the negative 10. For my axis of symmetry, I use the formula negative b over 2a. So negative negative 4 would be positive 4. And then over 2 times 3, of course, is 6. And that reduces down to 2/3. So let's graph what we have so far. So my y-intercept is a negative 10. There it is, right there. My axis of symmetry is at 2/3. So if that's 1, just do your best and plot where you think the 2/3 would lie. Okay, next what we need to do is to find the vertex. We are going to plug that 2/3 into the original equation. So 3 and then times 2/3 squared minus 4 times 2/3 minus 10. So we're plugging it into this right here. When you're dealing with fractions, just plug it right into the calculator. There's no point in making this painful. So 3 times 2/3 squared minus 4 times 2/3 and minus 10. Okay, so it's about negative 11 1/3. Okay, so if this was 10, there we go, we've got negative 11, negative 12, so negative 11 1/3 would look just about like that. All right. And then the last thing we do is we mirror image this over here. So if this is 2/3 of a unit away, we go another 2/3 of a unit to 4/3. So we'd plot that symmetry point right about there. Okay, now before we graph our parabola, take a look back at the sign. Sign is just a less than, which means our parabola is going to be dotted. Okay, so our parabola will look like that. Very last thing, we need to figure out where we're going to shade. So we always use our test point of 0, 0. So is 0 minus 0 minus 10 less than 0? And yes, it is. Yes, it is. So we end up graphing this part right in here because 0 is true. All right, so there we go. Very last problem, number 25. Okay, so we've got x squared plus 6x is greater than a negative 5. Okay, so I'm going to do this the easiest way I can, which I think is the algebraic way. So first thing I'm going to do is I'm going to add the 5 to both sides so I can get it in standard form. So now this inequality right here factors down, got x, x. So we want to know what multiplies to 5 and adds to 6. That would be a positive 5 and a positive 1. Okay, so our x-intercepts are negative 5 and negative 1. So I'm going to do the algebraic way, where we set up a number line. So here's my negative 5 and negative 1. Remember what I technically just did is I split up my x-axis into 3 different sections like this. And so I can test a different value. So I can test something like negative 6 or negative 10 or something like that. And you can plug it in here. Okay, so I want to see if this equation, this inequality, is true or false. So if I plug in a negative 10 squared plus 6 times negative 10 plus 5 comes out to be 45. 45 is greater than 0, so a test value in here came out true. Let's plug in something in the middle, like negative 2, for instance. So negative 2, oops, that's 20, squared plus 6 times negative 2 plus 5. That comes out to be negative 3. Negative 3 is not greater than 0. So something in here comes out false. Something bigger than negative 1, let's use 0, because 0 is the easiest one ever. 0 plus 5, that's of course 5, which is greater than 0, so this region comes out true. So what I want to do is I want to identify this region right here and this region right here, just describe what those x values are. So these were all the x values that are less than negative 5, so I'm going to write x is less than negative 5. This is just a less than because this is just a less than. If this had the or equal to, so would this. Then I write or, these are all the values greater than negative 1, so I write x is greater than negative 1. And that would be your final answer. All right, so that's our last problem. Study hard and good luck.